Okay, so today I'm going to explain few of the examples of disk scheduling algorithms. The very first one, it's a first come first serve scheme. So what we are having as an input is the work queue that shows us the different cylinder numbers, that is 23, 89, 132, 42 and 187, and the range of cylinders we are having at the moment is from 0 to 199. So altogether these are 200 cylinders. Currently the head is placed at 100th cylinder. So how we can implement these algorithms? So first come first serve is very simple algorithm. It says that the head moves to those cylinders which are appearing first. So in our case the head is placed at 100th cylinder, and the very first cylinder which is appearing in the work queue is 23. So the head moves from 100 to 23, and then 23 to 89, and then 89 to 132, then comes back to 42, and then finally reaches to 187 basically. So we can make the difference between different heads movements and can calculate the total number of cylinders which we access. So in first come first serve you can see that we are having different haphazard activities, that if we are standing at the 10th, we are coming down and goes up and down, up and down. So it makes different uh, actions, so which gives a huge amount of seeking time, because when the head moves from 100 to 23, it travels this long journey, so it takes time. So in the meanwhile, if I am accessing 89 and then 23, so during this travel from 100 to 23, we can even access 89 as well as 42. So this will reduce the complexity or the access time of the disk scheduling scheme. So we we can say that FCFS is not the optimal solution for our case. So there is another one which is basically shortest seek time first, that is the number second algorithm. And in this one we need to calculate the difference between different cylinders. So wherever we are standing, we need to calculate the difference of cylinders from all the values, and we need to identify the shortest seek time cylinder, so we can travel from the current position to the next destination. So in our case we are standing at 100, so if we subtract 100 from all these work queues, so we can identify that the nearest one is 89, and after 89 the nearest one is 132, and after 132 the nearest one is 187, and then the nearest one is 42, and finally 23. So these are the nearest one among the sequence. So here you can see that 187 and 42 is very far, but when we are reaching 187, we have already consumed 132 and 89, so these are not in the queue. So when we are standing at 187, the only two remaining cylinders are 42 and 23. So if we make a difference of 42 from 187 or 23 from 187, the shortest one is 42 cylinder. So we need to jump from 187 to 42, and then 42 to 30, 23. So this scheme is basically your shortest time first. Shortest seek time help us to identify the sequence in which we can move the head from one cylinder to another cylinder where the traveling is least. So we don't need to travel far uh, to identify any cylinder. So this is very much optimal in our case. Then there is another one which we can say scan, which is basically an elevator technique, and in this scan we need to move from one single direction. So if we are at 100, so either we can go up or we can go down. So in this example we are moving towards 0, so we are moving inwards. So from 100 we move towards 0 and we seek all those cylinders during this journey, and from 0 we move towards the other end of the sequence, that is 187, and we will seek all those cylinders which comes this particular movement. So scan is another good way to read all those cylinders, but the direction is all the time one-sided. So from 100 it moves towards 0, then bounce back towards 187. So here why we are moving, while we are hitting 0 in a scan, we need to hit the boundary. Technically 0 is not the cylinder which we need to access, but in this scan we need to hit the boundary and then bounce back. So we are traveling axis from 23 to 0, which is not required technically. So there is another modified algorithm, that is look. It helps us to eliminate this overhead. So in this case, in the look, we can see that we are moving towards the inward direction from 100 towards the least one, but when we reach 23 we don't need to go more further to the 0 value. We bounce back and we reaches to the highest required cylinder. So look and scan is very much alike, but look is the advanced form of the scan, which eliminates the bouncing of the boundary element. Then there is another scheme of this scheduling, that is circular scan, or we can say C scan in short. This scan technique help us in this way that it reads the cylinders only in one particular direction. So if we are moving towards inward and reading towards the inward, so it always reads in the inward direction. It never reads the cylinder in the outward direction. So if we are moving from 100 towards 0, it reads all those cylinders which is during this path, and when it reaches 0 it bounces to the highest end, means the next side of the boundary, which is 199, and from 199 it starts moving again towards the inward side and starts reading the remaining cylinders. So this is another technique which is basically a circular one. So 100, from 100 it bounced inward towards 0 and reads from 0 to the next boundary. There is no need of reading because in this direction the disk is not reading, and from 199 it starts moving inward and it starts reading. So it reads only towards inward side or outward. So if we start from 0 from 100 and we move towards 199 and reads towards the outward side, so when we reaches to the 199 and bounce back to the 0, it will not read. So it reads only in one particular direction, whether it is inward or outward. C look, it is again the extended form of C scan, because in C scan you can see that we are reading excess cylinders from 23 to 0 as well as from 199 to 187. These are the excess cylinders which we are reading in this particular algorithm, and you can see that we are also calculating these values. So C look eliminate that particular part. So in C look you can see that from 100 towards the inward direction, when we reaches to 23, it bounces from 23 to 187. It does not goes down to the 0 and bounce back to 199, which we have seen in C scan. So it eliminates the boundary bouncing cylinders. So it reduces the complexity, and you can see that two particular blocks of reading are not required in C look. So it is technically more optimized in comparison of C look. So these are the disk scheduling algorithms, and this is the example which we have solved over here. So I hope that you guys understand. Thank you.